we continue to look at first order differential equations and finding their solution. Now, in previous videos, we used direct integration. But suppose the differential equation is of this form now. dy by dx is f of x and y. The fact is, the y on the right hand side will not allow you to find a solution by direct integration. Alright? So that won't work. So in this case, you might have something like dy by dx is equal to, say, f of x, f of y. You have the x and the y mixed up together. What you need to do is manipulate the equation so that on the left you have f of y dy equals, and then on the right you have f of x dx. Then you can integrate to find a solution. So let me see now. Suppose you divide both sides by f of y, you would have dy by dx is equal to 1 over f of y. And then you multiply, f of x is there. F of y. Yeah, so f of y cancel f of y. And then you have 1 over f of y. Because we divide by f of y. Let me redo it. Let me just write over the whole thing. My. You divide by f of y. So you have dy by dx times 1 over f of y equals f of x. Because f of y would be over f of y and they cancel, right? And then if you multiply both sides by dx, what you have is, let's put the f of y on the left. F of y dy is equal to, when you multiply, the dx will cancel, dx over 1, it will cancel, right? So here, you multiply by dx, so you have f of x dx. Alright, so you have a function in y dy equal a function in x dx, and then you can now integrate both of them. Alright, so you separated the variables. They were mixed up together here, and you do your maths and separate them. Whatever mathematics you have to do, add, subtract, multiply, divide, and so on and so forth. Alright, so let's look at a specific example. Let's just erase what we have here and look at an example with numbers and so on. Suppose you have dy by dx is equal to 2x over y plus 1. Alright. Now, you need to have the function in y dy equals the function in x dx. Alright? So what do you do? Just multiply both sides by y plus 1. We're going to have dy by dx times y plus 1 equals 2x. Alright. Then if you multiply both sides by dx, you're going to have dy times y plus 1, but put it as y plus 1. Dy is equal to 2x dx. So, there you go. Right? Now, here, you have the, you can consider the integral. You're going to integrate y plus 1 dy equal 2x dx. So what do you get? Integrate y plus 1 with respect to y. You remember the power rule. You're going to have y squared over 2 plus y. See that? Equals, integral here is 2x squared over 2, then plus c. These 2's will cancel, alright? Now, you don't necessarily have to put a plus c over here, because if you have a constant, call it c1, and this constant, call it c2, you could always add or subtract c1 from both sides. So you're going to have c2 minus c1, which is just another constant. Call it c3 if you want to call it that. But you only need the constant of integration on one side. Alright? So it's going to be y squared over 2 plus y equals x squared plus c. So that is what you have there. You have converted the differential equation to some polynomial equation.